Right, matrices test B. Always remember with matrices that you do have a calculator, and you should have a nice calculator like this. And these can do matrices if you ever need to multiply them. I'll quickly show you this one here. If you press exit to get all the way back out here, you can go to maths, matrices, choose your size, and then just type in whatever questions you decide. Right, let's do the actual question. Right, B minus A. It's quite nice. So it's just my value of B minus my value of A. So 3 minus minus 1, which is 4. Minus 1 minus 2, which is minus 3. 0 minus minus 2, which is 2. Minus 4 minus 5, which is minus 9. Okay, B minus A. Good. Right, B. 2A minus 3B. So I'm actually going to multiply them first. So I'm going to times A by 2 to make it 2A. To make it minus 2, 4, minus 4, and 10. That's 2A. And I'm minusing 3B. This B, so let's times it by 3. 3 times 3 is 9. Minus 1 times 3 is minus 3. 0 times 3 is 0. Minus 4 times 3 is minus 12. And now we just subtract them. So minus 2 minus minus 9 is negative 11. 4 minus minus 3 is 74 plus 3, which is 4, 5, 6, 7. Minus 4 minus 0 just leaves it as minus 4. 10 minus minus 12, which is 22. Okay, good. Okay, let's focus on the blue part first. So it's going to be minus 1 times minus 1. And it's going to be plus 2 times minus 2. Okay. And then for the bottom bit, I'm going to have to do minus 2 times minus 1. And then normal 5 times minus 2. Now if I look at these, my green bits, I know it's minus 1 times 2. And then 2 times 5. And then we have to go to the second part, which is minus 2 times 2. And then plus 5 times 5. Okay, and I just got to sort all these bits out. I'm just going to trust my calculator to do this. So here I've got minus 1 times, sort this out, minus 1 times minus 1, plus 2 times minus 2. I'll type it in properly. That's better, which is minus 3. That will now do minus 2 times minus 1, plus 5 times minus 2, which is minus 8. Here I'll do minus 1 times 2, plus 2 times 5, which is normal 8. Minus 2 times 2, plus 5 times 5, which is 21. Right, let's make it look like an actual matrix. Okay, next one is b to the power of minus 1. So 3 minus 1, 0 minus 4. Okay, minus 1. So if I'm doing anything to the power of minus 1, what that actually means is I need to use the formula, which is n to the power of minus 1 equals 1 over the determinant of m, and I need to change this as d a minus b minus c. Okay, and I assume this is in the form a, b, c, d. So let's do the last bit first. A is 3, c is 0, so it's still minus 0. B turns into a positive 1, and d is now minus 4. 1 over. Now I just got to work out my determinant for this matrix. And my determinant is AD minus BC, which is 3 times minus 4, minus 1 times 0. All this makes 0, so 3 times minus 4 is minus 12. And the last one, b to the power t, which is actually b transposed. I'm going to try it on top. Which is 3 minus 1, 0, 4. The easiest way that I try to remember it is that it's sort of like in a reflection of these ones. So my 3 and my 4 stays the same, and my minus 1 and my 0 swap. Right, find the matrix representations on the linear form of x, y. minus 3x, 2x plus y. So that should be P. And Q, xy, which is 2y minus x. And it's always good to write x and y here, just so I know which order they're going. So here I've got minus 3x, which makes it minus 3. I haven't got any y's, so I've got to put a 0. And here I've got 2, and that's a positive 1. For Q, again I always have to write my x and y's, just because it helps me out. I haven't got any x's, so it's going to be 0. That's going to be a 2. And for my y I've got a minus 1. This one here is going to be 0. Right, M, 1, 2, minus 4, 2, 1, 3, minus 1, 3, 0. Without using the calculator, show that M is non-singular. Okay, so what I've got to do is I have to work out the determinant, and it's non-singular if my determinant is not 0, and it's singular if it equals to 0. And my determinant of a 3 by 3 matrix is a little bit confusing, but I know it's going to be 1, and I ignore the row and column. Just give me 1, 3, 3, 0. And next one's minus, it's going to be my 2. And again, I'll ignore my rows and my column to make it 2, 3, minus 1, and 0. And then I ignore my negative 4. And that's going to be this one here, it's a bit easy to see. 2, 1, minus 1, 3. Now, okay, now I have to do is to work out the determinant of each individual ones here. This can be 1 times, that's my diagonal here, which is 1 times 0, which is 0, minus these two, which is 3 times 3, which is 9, minus 2. My diagonals here is 2 times 0, which is 0 again, minus 1 times 3 is minus 3. That's plus and minus, so minus 4. 2 times 3 is 6, plus 1, because of minus 1 times 1 is 1, and I'm minus them. So here, the brackets here equal 9, so it's 1 times 9, which is minus 9. That one there, which is, and I forgot how much I'm minus in, so this actually changes to a plus, so it's 2 times 3, which is actually minus 6. This one here is 7, so it's minus 4 times 7, which is 1428. If I do it on my calculator, just because I'm getting tired, minus 9 to minus 6, minus 28, which is minus 43. If I actually remind myself of a question, it says show that M is non-singular, and I've done that. We're working out the determinant is minus 43. Okay, so I've got this matrix here of 1, 2, minus 4, 2, 1, 3, 1, 3, 0. I've got, without using a calculator, I'll find M minus 1. We found out from the previous question that my determinant is minus 43. It's just always a little bit easier to remember that you can just type this into your calculator and press equals. So I'm looking for this horrendous answer. But let's do it without the calculator, just as it actually asked me to do. Right, so first thing I'll do is got to find the matrix of minors. Okay, so first one is a 1, 3, 3, 0. I'm ignoring these two, which makes it 2, 3, minus 1, 0. Then that one there is going to be 2, 1, minus 1, 3. Get one rows down. It's this one here. So it's those ones and those ones. So it's 2, minus 4, 3, and 0. And then that one is in the centre. Oh, that's confusing. Which is 1, minus 4, minus 1, and 0. And my last one here, which is 1, 2, minus 1, 3. And my bottom one, a little bit easier for me to see. 2, minus 4, 1, 3. That one there is 1, minus 4, 2, 3. And my last one is 1, 2, 2, 1. Okay, now I've got to find the determinant of all of these. I'll do it here. 1 times 0, 0. 3 times 3 is 9. Sorry, minus 10, so it's minus 9. Here, 2 times 0, 0. Minus 1 times 3 is minus 3, but remember we're subtracting it, so actually mine's as a positive 3. 2 times 3 is 6. Minus 1 times minus 1 is minus 1, but I'm subtracting it, so it's 6 plus 1, which is 7. Let's move down to 2 times 0, 0. And we're subtracting 3 times minus 4, which is minus 12. Remember, we're subtracting it, which actually makes it a 12. 1 times 0, 0. Minus 4 times 1 is a positive 4, but remember, we're subtracting it, so it goes back to minus 4. 1 times 3 is 3. Minus 1 times 2 is minus 2, but remember, minusing, so adding them, so it makes it 5. 2 times 3 is 6. And I've got to do 1 times minus 4 is minus, but remember we have to subtract them, so that minus becomes plus, so 6 plus 4, which is 10. 1 times 3 is 3. 2 times minus 4 is minus 8, but again, we're minusing that, so it makes 8. 3 plus 8 is 11. 1 times 1 is 1. 2 times 2 is 4. So it's just 1 minus 4, which makes it minus 3. Okay, I've just rewritten this just because my working out was getting a bit messy. I need to print around my signs. It goes minus, plus, minus, minus, plus, minus, plus, minus, plus. So I might need to change some of these signs around. That stays the same. This one changes to a minus. That stays the same. This changes to a minus. That stays the same. Changes to a minus. That stays the same. This changes to a minus. That stays the same. Now when I have to do this, I need to transpose this. So essentially I've just got to like reflect. So I'm going to start with the ones that are on the line. So I've got minus 9, minus 4, minus 3. Stay where they are. These two swap, so this becomes minus 5, that becomes minus 11. These two swap, so this becomes 7, that becomes 10, and my 3 and my minus 12. So this is minus 3, that is minus 12. And I'm not totally done yet, because I've put this 1 over the determinant, and I've forgotten what the determinant is, so let me check. Which is 1 over 43. And I could multiply all of these over by 1 by 43, but I just don't want to. Right, question 4. Triangle with vertices A is 1, 2, B is 1, 8, and C is 5, 2. Maths to T dash with the matrices 5, 1, 3, 2. Find the coordinates of T dash. Okay, so what I need to do is I'm going to need to multiply this matrix by each one of these. Okay, so 5, 1, 3, 2. Let's do it to A, which is 1, 2. And that's just my coordinates in the matrix. So the first one is 5 times 1, which is 5. Plus 1 times 2, which is 2. And next bit is 3 times 1, which is 3, and 2 times 2, which is 4. 5 plus 2 is 7. 4, 5, 6, 7, which is 7, 7. Good. Next one. Keep the same transformation matrix. And this one here is now 1, 8. So that's going to be equal 5 times 1, which is 5, plus 1 times 8. And this is 3 times 1, which is 3, and 2 times 8, which is 16. 8, 9, 10, 11, 12, 13, 19. And my last one, I keep the same matrix. And my third point was 5, 2. 5 times 5 is 25. So 5 times 5 is 25, 2 times 1 is 2. 3 times 5 is 15, 2 times 2 is 4. That's this, 5, 6, 7, so it's 27. 15 plus 4 is 19. So my new coordinates of A dash is 7, 7. B dash is 13, 19. And C dash is 27, 19. Now for part B, we have to find the area, and let's be honest, it's going to be a lot easier if I just draw a sketch of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be a terrible sketch because I'm going. Okay. Each one's 2, by the way. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 7's here. 1, 2, 3, 4, 5, 6, 7. So 7, 7. That's A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 19. So it's up here. So I'm drawing over this. And 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 23, 24, 25, 26, 27, 28. 28, so it's here. Oh, but this is also 19, so it's actually going to have the same height. So I'm looking for this horrible thing, which I really should not have drawn over each other. I'm so sorry that I have. So I need to find the area of this. Now, because this is a straight line, this is nice. I can work out the length of this straight line, because this is actually B and that's actually C. So if I start off at 13, I go all the way up to 27. I'm looking for the difference, which is 14. My height, So this one here is 7, and I'm going up to 19. So it's going to be 19 minus 7, which is 12. And now my calculation is 14 times 12 divided by 2. 14 times 12 divided by 2 is 20, so my answer is 20 units. UN squared. Right, describe fully the transformations represented by the matrices 0, minus 1, minus 1, 0, and B, a half, square root 3 over 2, minus square root 3 over 2 and a half. Okay, now if you think about A, let's think about our normal unit square. So this coordinate here is 1, 0, and that one there is 0, 1. Okay, that's now been transformed to that one there, which is 0, minus 1. Oh, this one, and minus 1, 0. And go this way. If you look at that, this looks like a reflection in that line there. So the answer is going to be reflection in the line x equals y. Okay, now if we look at this one, you've got halves, root 3 2's, minus root 3 2's and a half. If you see anything weird like this, it does look like a rotation. You then need to try and remember the equation for rotation of a matrix, just to make sure. Which are given in your formula booklet, but it's cos theta, so these two will be the same, they are the same there. And this one is a minus sin theta, and that's sin theta. And all of these values should be the same if I type it in. So that's on, do the cos one, so it's cos of, minus cos of 0.5, which is 60. So these two are 60, but let's just make sure. Let's do that one now. So let's do the sin minus 1 of minus root 3 over 2. And which is minus 60. Now, don't be thinking that because there's a minus between these, they are the same. They're not. Think about your sin graph. This could be minus 60, or this could be 300, or in other values. And just remember, cos of 60 is also 300. So because you've got to think about your other values of sine and cos, you've got to think about what else is available. So this is actually rotation of 300 degrees anti-clockwise. Right, part B. Find the coordinates of the image of the point 2 minus 3 after being transformed by a matrix A. So let's just write matrix A. 2 minus 3. And we'll times it by the point 2 minus 3. So 0 times 2 is 0. And then minus 1 times minus 3 is 3. And then we've got minus 2 times minus 1 times 2, which is minus 2, times minus 3, 0, which is 0. So it was going to be minus 2, which is perfect. State the coordinates of the invariant point of the transformation represented by matrix B. Because this is a rotation, the invariant point is always going to be 0, 0. So you can say the invariant point is 0, 0. It's done. The transformation R is an anti-clockwise rotation of the origin about an angle 0. Theta is in between 0 and 360, and is represented by a 2 by 2 matrix R. The transformation E is an enlargement of, and K has to be greater than 0 at the origin. Represented by a 2 by 2 matrix E. Write down the determinant of R and the determinant of E in terms of K. Right, so my rotation is going to be in the form of all rotations, which you have to know, which is cos theta, this is minus sine theta, and this is sine theta, and this is cos theta. So my determinant for this one here would be these two times together, which is actually cos squared theta, and then those two minus these two times together. This actually gives me negative sine squared theta. But because we're already minusing and there's a minus there, it actually becomes plus. If you've done your A level, remember your A level, this is actually a trig identity. Cos squared plus sine squared actually equals 1. So the answer is 1. which is nice. Now, if we think about the enlargement, my normal, let's do 1, 0, 0, 1. Okay, just my basic square. If I'm going to enlarge this by scale factor of k, this just becomes k, 0, 0, k, because it's just multiplication. Now my determinant of this will be these two multiplied together, which is k squared, subtracted by those two multiplied together, which is 0. So my determinant for E equals just k squared. Next bit, my matrix M, which is minus 2, 2 root 3, minus 2 root 3, minus 2, represents a combined rate transformation of R followed by E. So it's R, then E. Right, find the value of K and the value of theta. Okay, right, now we just got to think about the determinant and what that actually is. Now your determinant is a scalar value associated with any matrices. And because this is an enlargement, my determinant for this will tell me what the enlargement is, especially because we know that here it's 1. So if we work out the determinant of M, we've got minus 2 times minus 2, which is 4. And we minus these two minus together. So I've got minus 2 times 2, which is negative 4, which changes into a positive. Root 3 times root 3 is 3, which is 4 plus 12, okay, which is 16. And I know this is my enlargement. Well, I know this is actually going to be the same as my determinant here, actually, which is k squared. So that is my enlargement. If 16 is equal k, k's got to equal 4 or minus 4. It tells us somewhere along that k has to be positive. What's the question? No, that is k is positive. So it means that my scale has got to be 4. And so to really understand this, you've got to just ignore your rotations, because your rotations won't change the scalar of the matrix. Okay, now to work out theta, I've got my two matrices, got in the order it actually asked for in the question, which was R then E. That's my enlargement, that's my rotation. I'm going to multiply them together. I always mess up with this, so be careful. So I always cover this bit here up. So it's 4 times cos, which means 4 cos theta, plus 0 and sine, which is just 0. My bottom bit I'll do, which is 0 times cos theta, which is 0, plus 4 times sine theta. Now if I look at my next one, I do 4 times minus sine theta, which is minus 4 sine theta, and 0 times cos, which is just 0. And I do 0 times minus sine theta, which is 0. 4 times cos, which is plus 4 cos theta. All my zeros actually cancel out, so I'm just left with 4 cos theta, 4 sine theta, and then minus 4 sine theta, and 4 cos theta. And from the question, I actually know the value of all of these, so that's exactly the same as minus 2 root 3, 2 root 3 and minus 2. Okay. And we all know that these are actually identical to each other, so we've got loads of equations we can choose from to really make. So I'm just going to make this one here. So I'm at 4 cos theta has to equal negative 2. I can easily solve that. So I have to divide both sides by 4. So cos theta equals minus a half. And we'll use my calculator to get what the angle is. It's just minus 1 of half. Oh, it's half minus half. It's minus a half. Equals 120. It's always good to check this. So let's check it with this one here. 4 times. Oh no, let's do this one because that's a little bit different. Minus 4 times sine 120. And minus 2 root 3. Minus 2 root 3. And then you notice that's a minus, and we really want it to positive. So we need to think about what other value could this actually be. So is there another value of cos of minus half, which is 120? And you have to think about your cos curve. My pen's not working there. So 120 is there. So we've got to think of this distance here, and when you work it out, it actually ends up being 240. And let's see if 240 works. So minus 4 sin of 240. Sorry, minus 4 sin of 240. Type it in properly, and you get 2 root 3, which is exactly what we want. So my answer's at 240 degrees theta. Okay, A equals minus 2A5, B for C, minus 3, 1, minus 1. Given that A squared is minus 21, minus 5, 0, 13, 3, 1, 11, 18, minus 17. Find the values of A, B and C. Okay, now I'm just going to square it. Now when I'm doing any multiplying of matrices, I always change colours because I find this to be a very confusing thing. And it just means that my working out is a bit neater in my head. So I'm actually going to work this out and see if anything that comes out only has like an A, a B or a C, and I'll compare it to this number and hopefully solve it. Okay, so let's start. Minus 2 times minus 2 is 4. Okay, A times B is AB, and 5 times minus 3 is minus 15. Okay, and I'll do the second one. Minus 2 times B is minus 2B. B times 4 is plus 4B. And this one is minus 3C. The last one, minus 2 times minus 3 is 6. Plus B. Plus 4. Now this looks promising because it's only got one B in, but I'm just going to finish what I'm doing, because that's what I do. Let's do the second one. A times minus 2 is minus 2A. Plus 4A. Plus 5. Second one, I've got AB. Plus 16. Plus C. My last one, I've got minus 3A. Plus 4. Minus 1. Okay, and my last colour, which was green, I think, yeah. I've got 5 times minus 2, which is minus 10. Plus AC. Minus 5. My second row is 5B. Plus 4C minus C. And my last one is minus 15. Plus C plus 1. Now if I look at my actual matrix here, I'm just going to write just below it so I don't get confused. Still keeping the colours the same. Minus 5, 3, 18. Oops, sorry. And another one was minus 21, 13, 11. So these two matrices are identical now. So you want to see is there one which hasn't got any, just one variable. And if you look at this one here, has got one variable and that's got equal to that one there. So I know minus 2 plus 4a is just 2a, so I know 2a plus 5 equals minus 5. 2a must equal minus 10. So a must equal minus 5. Okay. Next one I want to see if there's anything else just got an A, B or a C in. I've got this one here actually. Let's write in green just to be consistent. So this one here, I know actually equals to 17. So it's minus 14 plus C equals 17. To get this, I need to add 14 to both sides. So C's got to equal minus 3. And the last one. So I've got an A, I've got a C, I need to work out if there's one a B. Oh, there's a B here. So 6 plus B plus 4, which actually means 10B. No, 10 plus B equals 11. Sorry, I'm looking at this, I've actually realised that when I work this out, minus 2 times 1 is 6, 1 times B is B, minus 1 times 3 is 4, it's 3. So it's actually 9. Sorry, it's got 9 plus B equals 11. The B's got equal to 2. Okay, now I can check these answers if I wish. So if I get my calculator, I'll get my 2x2 matrix, so my 3x3 matrix, and I type this in and square it, I should hopefully get that one. So minus 2, I've worked out A to be minus 5, 5, B I've worked out to be 2, 4, and C I've worked out to be minus 3, and then minus 3, 1, minus 1. And if I square this, hopefully I'll get this one. Oh, minus 21, 5, 0, 13, 3, 1, 11, 18, minus 17. I'm right.